In this example, we're going to take a look at marginal average cost functions and how those differ from average cost functions and marginal cost functions. So here in example 4, we've got a total cost function of producing X TVs per week is given by C of X equals 10,000 plus 200X minus 0.1 X squared. Now I want to, in part A, I want to find the marginal average cost function. So marginal, that tells us to take the derivative. I want to take the derivative of the average cost function. So I'm really looking for what is C bar prime of X. Now how we go about finding this is really important. There's going to be 2 steps here, because all I have is the total cost function. All I have is C of X. So the first thing I'm going to have to do is find the average cost function. And then once I have that average cost function, then I can go ahead and take my derivative. I have to do the problem in these 2 steps. I can't switch these 2 steps around. So I can't take the derivative first and then try and find the average cost function by dividing by X. It would make our calculations a little bit easier, but that wouldn't be telling us what we needed to tell us. So we have to do the problem in these steps. So the first thing I need to do is find the average cost function. So first I need to find, well, what is C bar of X? Well, for this particular problem, well, for all particular problems, I want to find the average cost function. That's the total cost, C of X, divided by X. So my total cost, that's 10,000 plus 200X minus 0.1 X squared. And I'm going to divide that whole thing by X. Now, in the last example, I said, okay, if we're not doing too much else with the average cost function, you could just leave it like that and be done with it. But I am looking ahead and thinking, well, my next step is to take the derivative. So I want to take the derivative of this function. Now, if you think back to section 2.5, one of the things we said is that the derivative doesn't really play nice with division or multiplication. It doesn't really agree with those. So we're going to have to find a clever way to rewrite our function here so that we don't have division, or so that we can use our power rule, because right now that's really the only tool that we have to use. So what I'm going to do is I'm going to take each term in my numerator and divide it by X. I'm going to take this one fraction up and split it into 3 separate fractions. So I'm going to rewrite this as 10,000 divided by X plus 200X divided by X minus 0.1 X squared divided by X. So again, I'm kind of thinking ahead a little bit to what's my next step? Well, that's going to be to take the derivative here. So I want to simplify each one of these 3 terms and write them in a way so that it's easier for me to take the derivative. So if we start with our first term here, 10,000 over X, I say, okay, if we're going to take the derivative of this, I can't really do that while X lives in the denominator, at least not with my power rule. So I need to rewrite that with a negative exponent. This will say 10,000 X to the minus 1 power. And this is just going to make it easier for us in the next step to find our derivative and use our power rule. So that's our first term. The next 2 terms should be a little bit easier. Here I have 200X divided by X. Well, we can just cancel our X's and we're just left with 200. And then finally for our last term, we have negative 0.1 X squared divided by X. Here we can cancel a power of X and we're left with minus 0.1 X. Now be careful. I have not actually taken the derivative yet. I've only written this in a way so that it's easier for me to take the derivative, or so that I can take the derivative. So this is still C bar of X. I've just been rewriting my average function so that I can, in the next step, take my derivative. So now I have each of these terms separate. I can just use my power rule on each one of them. C bar prime of x is equal to, multiply by our power. Here I should have negative 10,000 x, and then subtract 1 from our power. Be careful with these negative signs here. I should have x to the minus 2 power after I subtract 1. Derivative of 200, well, that's just a constant, so its derivative is 0. And then minus 0.1x, that will become minus 0.1 after we take its derivative. So here is our marginal average cost function. Now, if you wanted to leave your answer like this, that's perfectly fine. But I'm kind of looking ahead at part B. Part B says find the marginal average cost at a production level of 100 TVs per week. Generally, I don't like to work with negative exponents. In my next problem, I'm going to have to take 100 and plug it in for x, and I just don't like working with negative exponents. In general, we just don't have as much experience working with those. So what I'm going to do is I'm going to rewrite this as c bar prime of x as negative 10,000 divided by x squared minus 0.1, just so that I don't have to deal with the negative exponents. Either one of these answers is perfectly fine for your answer to part A. I just like and prefer to work with positive exponents. I think that we are just a little bit more comfortable with them, and like I said, we have more experience working with them. So that is how I would write my answer, but either one is perfectly acceptable. For part B, again, it says find the marginal average cost at a production level of 100 TVs per week. So I'm going to take 100, I'm going to plug that in for our x value. C bar prime of 100, well, this is negative 10,000 divided by 100 squared minus 0.1. Now, if you grab your handy-dandy calculator and you plug that in, we should end up with negative 1.1. Now, this is marginal average cost. We're still talking about dollars and cents here, so I'm going to put a unit on this. This is negative $1.1, or $1.10 might make a little bit more sense. Get it? Pun, sense. Here to talk about. So here I'm just going to plug 100 in for x. You would get the exact same solution if you had plugged it into that top formula as well. You just want to be careful when you're working with your negative exponent. So there is my marginal average cost at a production level of 100 TVs per week. Part C, probably unsurprisingly, I want to talk about what does this number actually tell me. So that number, first of all, depends on our production level. So before I do anything else, I want to make sure that I mention our production level. So I'm going to say at a production level of 100 TVs per week. So, okay, that's our intro, our production level of 100 TVs per week. Think about, how did we find this number? Well, we found this number by plugging it into C bar prime. C bar prime, this is the derivative of my average cost function. So the derivative, this tells me the rate of change of my average cost function. So it describes the rate of change of my average cost function. So here it's the average cost function that's changing. So the average cost per TV is, and I'm going to think about, okay, so this is, the average cost is changing. This number can change in one of two ways. It can go up or it can go down. Well, in this case, our answer was negative for part B. So since our answer was negative, the average cost is decreasing by $1.10 per TV manufactured. So we can interpret marginal average cost very similar to how we interpret average cost. The one thing that we need to make sure that we're mentioning, though, is that it's the average cost that's changing, not the total cost. Otherwise, the interpretation is going to look very, very similar to how we interpret the average cost.